Hello everyone, and welcome to this theory recording on methods of analysis. So in this section, we're going to be covering the following subtopics. We're going to look first at nodal and mesh analysis. Then we're going to look at supernodes and supermeshes. We'll look at analysis by inspection. And finally, we'll take a look at transistor circuits. So first, nodal analysis. So what is nodal analysis? It's also known as KCL, which is Kirchhoff's current laws. So we use Kirchhoff's current laws in a node to determine the nodal currents that are either flowing in or out of a particular node. So KCL states that the arithmetic sum of all currents entering and leaving a node is 0. This implies that the sum of all currents going into a node is equal to the sum of all currents leaving that node. So if we take a look at the diagrams, you can see first that on the extreme left, you can decide the direction of any currents. This would have been indicated in any of the KCL discussions that would have taken place, that you can decide any direction for currents to flow in and out of a node. So here we decide that all currents are flowing into the node. Therefore, I1 plus I2 plus I3 gives you 0, which is the sum of the currents going out of the node. The second diagram shows you having selected I1 and I2 flowing in whilst I3 is flowing out. So I1 plus I2 gives you I3. And then the third diagram shows you having selected I1, I2, and I3 all flowing out of the circuit. Therefore, 0, which is flowing in, is going to give you I1 plus I2 plus I3. It's important to note that in as much as you can decide any direction of current to flow, that it is important that you express the current correctly. And the equation to express the current is the equation you see on the right hand side, which is that the current is always going to equal to the voltage of the higher potential minus the voltage of the lower potential over the resistance. So if I have a resistor connected between terminal V1 and V2, and I decide current is moving I1 from left to right, then that current must give me the voltage before the resistor V1, which will be assumed is the voltage of higher potential, minus V2, which is the voltage of lower potential over the resistance R. And if, for instance, I decided that I wanted the current to move from right to left, then I would say I2 is equals to V2 minus V1 divided by the resistance R. Now, if we look at this example, in this example, we're now given a circuit and we will semi-complete this just to determine the currents, the nodal currents. So we're going to look at node V1 and we're going to look at node V2. So in node V1, we know that we can decide any direction of current. So we're going to say that goes in, this goes out, that goes out, and that goes out. So we've got a node which has 4 branches, so therefore we're going to have 4 expressions. Right, so we're going to say KCL in node 1. And we're going to say first the current I1 is going in and I2 goes out plus small I2 plus small I1. And what will small I2 and small I1 be? Small I2 is going to be V1 minus V2 over R2, and small I1 is going to be V1 minus 0 over R1. If we look at KCL node 2, we're going to say the current I2 plus the big current I2 gives you I3. So I2 plus I2 gives you I3. I2 plus small I2 we said is V1 minus V2 over R2. That's going to give us I3, which is V2 minus 0 over R3. And with these two equations, equation 1 and equation 2, your unknowns will typically be your V1 and your V2, and we will use this to then solve the voltages. So we've got two equations with two unknowns. We're going to use that to solve the voltages. Remember, I1 and I2 will be given in the circuit. So we solve for V1 and V2. And this is the procedure that you would follow when you are using nodal analysis. You express the currents in terms of the unknown voltages, and then you solve for the voltages, in this case V1 and V2. And then if there were any other unknowns, you will then use the voltages to then determine those unknowns. Thank you for watching this video and enjoy the course.